Hello and welcome to another episode of the Fully Charged Show podcast, where today I'm sitting down with Ryan Hughes, an incredible engineer and creator of the YouTube channel Ziroth, a channel dedicated to telling phenomenal sustainable engineering stories. Honestly, you're in for such a treat. But before we meet Ryan, I've got two very quick things to tell you. First of all, my name is Imogen. I'm one of the presenters and producers here on the Fully Charged Show and Everything Electric Show. And whilst, of course, I am extremely biased, I do highly recommend that you go and check out both of those YouTube channels after this little audio journey into the world of engineering sustainably. And secondly, I need to tell you about our live shows. Next up, we're in Vancouver at the start of September, and it is going to be a veritable feast of electrification. We're talking thousands of EV test drives, loads of home energy technologies, some phenomenal speakers, and of course our home energy advice zone, ready to answer all of your questions related to your own property and your own clean energy transition. And of course, we'll be there, and it is always so wonderful to meet you, our lovely listeners and viewers, and to find out what you care about, really. So do come along, check out all of the details, they are in the description box below. But enough of that, let's buckle up for two nerds swapping some very nerdy stories. Ryan, thank you so much for joining us today. The last time that we caught up properly, it was with Ricky Roy of 2-Bit Da Vinci fame and also Fully Charged Show fame. And we got very into the weeds, maybe fueled a little bit by several beers, into the sort of weird quirks of YouTube and all of that kind of stuff. But how are you today? How are you doing?
I'm good. As you know, I've been having a disaster of things here at my end. I'm currently on a laptop perched on top of some chopped tomatoes with pillows all around me to try and make the audio better as I get as close as I can to my internet router. So it's been a bit of a journey to get to the screen today, but I'm very good. I'm very good.
And we're here, and I should say that because we were going to record this yesterday and there were some internet issues, and knowing that you are obviously a YouTube creator, I imagine you have some pretty fancy setup, and as such that must have been a bit of an unprecedented disaster. So I was like, I can only imagine your panic, and I am more than willing to be extremely patient in this regard. So
It's made me start looking up Starlink. They're thinking that maybe the outskirts of the countryside need some satellites to beam me some internet versus trusting these copper cables.
oh my gosh, we definitely, when we first moved into our house, I was like, is this what we're going to need? But yeah, managed to avoid it. Okay, I want to start by giving the audience a little bit of context, and I'm looking at my notes here because I want to make sure that I get this right. But you are a proper engineer, and specifically, and I'm quoting you on this, a multidisciplinary engineer interested in all projects with an environmental focus, specifically electrified transport, energy storage, and energy capture devices. And I just want to share a couple of other things with the listeners and viewers that really illustrate that point. A couple of summers ago, you designed and built a robot platform to teach undergraduates coding skills. Casual summer project. You did a degree in mechatronic engineering at the University of Bath, where your dissertation was in cold start procedures for solid-state batteries in automotive applications. Actually, I'm going to pause on that for a moment. First of all, what is mechatronic engineering, for those who don't know?
Yeah, so mechatronic engineering is the combination of mechanical and electrical. That's kind of where it gets its name. But then that brings in a lot of software. So I always say it's mechanical, electrical, and software engineering or computer engineering merged together, which often goes into robotics. That's like a pretty normal application for mechatronics, and it's got a cool name. But what really interested me was renewable energy systems, electric vehicles. You can't just know about one type of engineering, really, if you want to work on it, especially on a systems level. So mechatronics was this awesome degree, awesome discipline that gives you a little taster of everything. So you're a bit of a master of, no, jack of all trades, master of none, but it's an awesome degree.
You're absolutely right that mechatronics is such a cool word to say. And I can imagine sort of, if you said that to your 9-year-old self, they'd be like, mechatronics, that sounds like, you get to play with Meccano all day. But and I'm sure this is something that we'll come on to as we work our way through this. But I mean, I did not do mechatronic engineering. I did what I think is called engineering science at Oxford. And that means that you do like a load of maths, you do loads of sort of common modules in the first year, and then you start to sort of specialize over time. But one of the things that I found really interesting was when you did the biomedical, or when one did the biomedical engineering kind of modules. Actually, that was one of the other disciplines where it brought together electrical, mechanical, bioengineering, chemical engineering, and I absolutely adored it for that kind of very multidisciplinary approach. But cold start procedures for solid state batteries. Pray do tell, what is that?
Wow, how long have you got? Is that was my summer dissertation for my MSc, and it's solid state batteries. I'm sure a lot of the listeners and yourself know that they're these seemingly 5 years away technology. But what some people may not know is that there are solid state batteries currently in operation in vehicles. There's a company in France that use solid state batteries in electric buses. So the problem with these solid state batteries is that the solid electrolyte, which is what makes them solid state, normally batteries in most commercial electric vehicles have your liquid electrolyte, but the solid electrolyte allows you to have new anode and cathode materials that allow higher energy densities. But the solid state batteries that we have currently in these electric buses are a polymer solid electrolyte, which means that they gosh, I could go. My brain is thinking, where do I take this? But these polymer solid electrolytes, they work. They block dendrite growth. They do all the things they need to do, but they only conduct electricity effectively above 60 degrees Celsius, ideally in sort of 70, 80 degrees Celsius. So cold start procedures in automotive applications is basically saying, is there a way that we can use these solid state batteries that need to be 60, 70, 80 degrees Celsius, whilst not sacrificing consumer usability by making them preheat their car every time. So not only would you have to keep your car charged, if every time you want to drive it, you'd have to preheat it to 80 degrees Celsius. So instead of that, can we just use waste heat on the vehicle to heat them up in time? So it was this study of basically splitting a solid state battery pack that needs to be at 80 degrees Celsius into small modules that each module is sequentially heated using waste heat elsewhere on the electric vehicle, and then you've got a small liquid electrolyte, normal lithium ion battery that would kick off the whole thing, and at the end that would recharge. So you've always, when you want to go, you've always got a small lithium ion battery with liquid electrolyte, kind of like a hybrid electric vehicle that you can get going with. And then while you're moving with that, all of the waste heat that's generated from the battery, from the motors, elsewhere, can get redirected to these solid state batteries so they heat up in time. And the conclusion was, theoretically, yes, you could use waste heat from the vehicle to keep these modules warm enough. But in practice, it's engineers, you can think in theoretically of equations and energy balances, but then you try and make the system and you realize that's a lot of piping, that's a lot of other constraints. But it proved other points that I found of how you could size the system in terms of insulating these packs to make sure that they always keep themselves warm enough. So once you have heated them, they keep going. But it was an interesting thought exercise, but I think we probably won't be seeing that in commercial vehicles.
But I'm sure you said in many other interviews subsequently that, and I more mean sort of PhD interviews and job interviews and that kind of thing, that, wow, what a wonderful learning opportunity, and all the other bits and bobs that kind of emerged from that, even if it was to eliminate it as a viable technology.
Exactly.
But you're currently studying a PhD in machine learning for temperature estimation of electric machines. Can we have a sort of, headline? What does that actually mean?
Yeah. So, and this is where my brain I always have to stop and think, okay, what point am I trying to make before I ramble about something for too long? So the overall summary is, in an electric machine, there are a number of places that are really hard to measure the temperature of. For example, the rotor, the spinning part of the electric machine, could be spinning tens of thousands of times a minute. So to put a physical temperature sensor on that is possible but extremely expensive, so it wouldn't happen in most electric vehicles. But it's really useful to know the temperature of these places because they're, I mean, for safety, for efficiency, for a whole, for age prediction, understanding when the electric motor is going to give up. It's really useful to know temperature in as many places as possible on these electric machines, but you can't always measure it. So the point of these machine learning models that I've been developing is to take all of the information that we can easily measure, for example, the speed of the electric motor, or maybe the temperature in easy to access places, and the currents and voltages, and use that to predict the temperature in these hard to measure places. That was the sort of original aim. So it was trying to work out the temperature of the rotor using easy to gather information, which is a real art in itself. A lot of Formula E, Formula One teams that have hybrid systems, you'll use these crazy complex algorithms to try and work out the temperature of their electric machines to make sure they don't overheat. But they're all really not very accurate. It's kind of a stab in the dark. So these models can really improve that. But it also meant that if we now know how we're going to be driving this vehicle over the next hour or so, maybe it's a racetrack and you think, oh, I want to go hard around the next bend and then gun it down the straight, you can use that information to now predict how hot the temperature of the motor is going to be ahead of time. So these virtual sensors, as they're kind of referred to, not only can you measure or predict the temperature of hard to reach places inside your electric motor, you can also predict what they're going to do into the future if you know how you're going to drive your vehicle. So, and the speed at which they do it, I think, am I right in thinking you did some aerodynamics or CFD type things for Jaguar?
Yeah.
Those simulations are so slow. Like you need big supercomputers if you're going to do any kind of physics-based thermofluids or anything like that. So these machine learning models, you can predict an hour, 2 hours of thermal data, thermal behavior in seconds on a Raspberry Pi or like a tiny computer. So they are so useful. Obviously, there's pros and cons to everything, but for real time monitoring onboard vehicles or predictive modeling, they're super useful.
Do you know, and that is the extraordinary thing. So you're right. I was a aerodynamics engineer at Jaguar Land Rover approximately now. How old am I? I mean, we're talking 8 to 10 years ago. And it is absolutely remarkable what has happened in that time, because there was this instance that if you didn't set your simulations off by Friday afternoon, you would absolutely screw yourself over for the following week because those simulations took so long. So you'd need to capitalize on those 2 days of running time over the weekend, such that hopefully you'd have your results by Monday and if not Tuesday. And if you didn't do that, then you'd lose like half the week of work. And now, and I've been in quite a lot of sort of panel discussions and various forums recently, and understanding all of the machine learning tools that are now available that can capitalize on existing data that may exist within an automotive company to look at these very intractable physics problems, apply machine learning, and then suddenly you've got these incredible, the machine learning, that's such a reductive term, but machine learning tools acting as a co-pilot to the engineer. And then you've got these things that are happening more in real time. And if they're not 100% accurate, they are at least sending you in the right direction to then pursue that area rather than, covering the whole shooting match of different bits. So I think that's really helpful context that frames why it is you can cover the sorts of topics that you do on your YouTube channel, Ziroth, or if Ricky was here, Ziroth. So can you tell the audience, for those who might not be familiar, what is your channel? What's the goal and what sort of stuff do you cover?
So the headline that I would say the Ziroth channel covers is energy efficient engineering. That would be my capsule sort of overview. And what I like to do is normally interesting or unusual energy technologies. Maybe they're new propeller designs, battery designs, new turbines or solar panels, anything like this in the energy engineering domain. Look at it and do a real over analysis deep dive that no one else would care to do, and then compact it into a story driven, somewhat hopefully interesting package that forms these sort of 10-12 minute videos that hopefully use that energy engineering topic as a canvas or as a centerpiece to then form learning points for lots of other engineering topics. So every, I mean, as I'm sure you know, like the same engineering topics come up over and over again in different places, and I try and pick one of them. Maybe it's cavitation one time, maybe it's superconductivity, or maybe it's boundary conditions. Like all of these generic engineering terms, which are applicable well outside of anything I'm covering, but use these cool technologies in the energy space as sort of centerpieces to talk about it, and just gives me an excuse to go down these rabbit holes and talk to interesting people as well. And yeah, I guess the aim of it is to share this passion and try and put some interesting information out there that otherwise is pretty damn difficult. Like the extents I go to find this information are not small, so they're hopefully giving information about technologies that you can't really get anywhere else.
Do you know, I think that is an absolutely perfect summary, because I went down a bit of a rabbit hole myself the other day, kind of going through some of your back catalogue of videos. And it's so interesting because each one, exactly as you describe, you take a topic and you wrap it up in a story. So the one I'm thinking of immediately is the biomimetic LEDs. And
Yeah.
it's incredible because, and for those who haven't watched the video, I highly recommend that you go and watch the video. And it's all around, well, LEDs are very efficient as a generating light, but not necessarily in that light emission outside of the bulb that it's contained in. And so actually, can you use biomimicry and sort of learning from nature and create a much better efficiency of that actual light getting to what it's trying to light? That's really bad English. This is why you do what you do and I do what I do.
This is why I have a script.
But then I think what was so phenomenal about when you watch any of your videos, you kind of start with a topic and you're like, and you can feel yourself asking a question. And then before you've even thought that question, you've gone down the next little drop down menu and the next drop down menu and next drop down menu to add and add and add these layer of details. And it really disguises very technical subjects in an incredible way. And I was thinking, I wish I'd had this kind of resource when I was at school, that you can hide technical subjects inside a story. It's really, really, really cool.
That's
But
really sweet. Thank you for saying that. Yeah, that means a lot.
well, I mean, I can imagine it is no easy effort. How on earth do you begin to identify some of these stories? Because they're always like pretty topical, it seems.
Yeah, so in terms of the idea generation side of it,
Mm.
the it's kind of like a funnel, I guess, where I'm constantly, just out of my own interest in part, always reading every energy engineering news source I can see. All of my friends and connections on LinkedIn are sharing things, so I'm just like scrolling everywhere, looking on Reddit, at different paid subreddits, and just news sites. Everything starts this big funnel at the top, and maybe if there's like some interest around a topic or it looks particularly interesting, I'll start to like funnel them down. Some of them are my own tangents, and I'm like, "What are you thinking, Ryan? That's completely random." And yeah, this huge sort of upper funnel of ideas gets narrowed down into things that match a set of criteria that I have in terms of what the channel should be covering or what people might be interested that it covers. And this workflow of going from 100 ideas to one idea is something I've been fine tuning probably the most out of anything on the channel, potentially, because that idea is really the seed for everything else to grow from. If you've got a bad
Mm.
idea, or not necessarily a bad idea, but an idea that isn't a good fit, then you're really setting yourself up for a tough time in terms of making it interesting. So out of all of these ideas, there's a number of things that will decide it, but at the end, it's any idea that ended up getting down there. The filtration process is mostly to make sure it's a match with my channel and the audience. But then once you get an idea, it's you don't know what you don't know about these things. Like everything you study just has this whole world behind it. When I was at the Fully Charged show at London, the Everything Electric London, I was talking to the sound engineers and just got in this deep conversation about all the different like considerations to make sure sound hits people at the same time. And it's like I could do a video on a speaker that and go into such a deep dive and speak to experts for weeks to find out all these things around it. It wouldn't be a suit for the wouldn't be a fit for the channel. But yeah, the idea of process starts big, narrow it down based on fit, and then deep dive, and always it'll be this whole world that you don't even know about.
And I suppose there's two things that kind of come up there. The first is that how do you calibrate something that you just find really interesting, but actually your audience might be like, look, Ryan, we really don't care about that. And that's something that I definitely know that I experienced. I'm like, oh my God, this like new battery technology is so cool. And then the rest of the team are like,
Yep.
don't think so. And then I think the second aspect is that I bet you've seen that graph where it's kind of like the less you know, you have this sudden peak of confidence. And then like the more you know over a greater period of time, you go into the trough of disillusionment where you become so aware of the level of detail that you don't know. And understanding how much detail to go into in a technical video can be, yeah, I guess a bit overwhelming at times as well.
For sure.
How do you kind of balance those two things?
So yeah, on the first one, that's, I guess I'm the same, and I will find anything and everything interesting, and that is not always good for a business side of things. It's great for personal interest, but to refine things down to a point where only ideas that I think will be interesting get through, which sometimes is not always the case, then it's so my girlfriend's a psychologist, and
It's
often
quite
I thought
handy.
it's my secret weapon. I often say, because I'll be filtering down these ideas before, and I'll get carried away, or I'll think too logically about it, like, oh, this has had good engagement on other sites, so therefore people might find it interesting. And then Lois, my girlfriend, will be like, okay, but what do the people that watch your channel actually think about this? And then it becomes a completely human-centered conversation of what topics make it versus an analytical one. And that was the biggest step change, is thinking of the viewers as people rather than this analytical game, which obviously my engineer brain wants to do. So that's how I try and like focus it down to ideas that are interesting. You don't always like hit the mark, but if I let my brain just do what I thought was interesting, the channel would have no theme. It would be completely crazy. I'd like be going off on all different tangents. So really, yeah, thinking of the person, and there's get onto that more later, like algorithmic, thinking and all this, but remembering people are involved in uh, trying to understand what that group of people might think collectively versus just you as an individual.
Yeah.
Which is easier said than done, for sure. And then, what was the other part? There was a second part to that.
Oh, that's a good question. I think it was around assessing the level of detail to go into and not letting the kind of a full awareness of just how much there is that you don't know kind of stand in the way of
Yeah,
actually putting anything out in the first place.
yeah, that Dunning-Kruger effect of thinking, yeah, the unknown unknowns are the really dangerous
Mm.
ones. So trying in different topics that present differently. So maybe my next video that's hopefully coming out tomorrow, um, covers something where there was very little information available, lots of news articles, but no technical information. And that is prime for Dunning-Kruger effect, because you read it, you think you understand, and then you could present this whole video, which is a technical analysis on the wrong thing, and maybe the
Mm.
technical analysis is right, but it doesn't really fit with the technology. It's a lot easier when it's something based on like academic papers or research groups that are extremely transparent, because you can instantly be like, oh wow, that's really interesting, I didn't think of that. And you, even if you don't understand it, you've suddenly got a list of all of the unknowns, and now you're aware of the unknowns you don't know about this technology, at
Mm.
least to an extent. So that is the key thing, is trying to find all of the things you don't know about the technology, and then picking which ones sound interesting and deep diving on them.
Mm.
And the process of doing that now is often really prioritizing trying to speak to the company that's making that technology, because that's the best sourced,
Yeah.
but also to eliminate bias and get other viewpoints, I've got a panel of experts who I can call upon to say, can you help me? What do you think about this turbine? What do you think about this battery? And that's super helpful for them illuminating all of my blind spots, because once you know the landscape, it's much easier to pick out what to cover and what to look into. And when you know what questions to ask and when you know what you don't know, it's infinitely easier to like find the answers. It's not that challenging if you give me a topic for me to go and research it and find out about it and learn about it. But coming up with that list of topics I need to know about for a video can be cripplingly difficult. So to answer that, yeah, of how I try and avoid that is speaking to experts, speaking to the company, trying to illuminate this space. If there's research, if there's patents, literature, anything like that, just to try and illuminate all of my blind spots, and then go down and find which one to really make the video about.
Which takes, I think, an enormous amount of humility and kind of self-awareness, because, you know, when you're talking about technical subjects on YouTube very publicly, it could leave you feeling like pretty exposed. And something that I find remarkable, and I'd be interested to get your thoughts on this, is that quite often when we go through that process of, okay, have we understood this topic correctly? Have we gone into sufficient level of detail? If pressed on this, have we got an answer to it? And you do all of that, and then you release the video. And invariably there's a comment in the comments from somebody, and you're like, yep, we absolutely should have thought of that. Thank you very much. And it's so wonderful and so helpful when people do provide that. I would caveat that with constructive feedback or generate debate in the comments, because it kind of, you can't cover everything, and it's really interesting to see how that could lead to a second video or continue the conversation.
Yeah. Oh man, the comments are the best and worst thing, because they can be, when they're not constructive, it can be harsh. But so often, say my video is getting viewed by hundreds of thousands of people. There's going to be a world expert. There's going to be a handful. There's going to be quite a lot of world experts probably on the topic I've covered watching it. And when maybe I've spoken to one expert, but that expert has a blind spot, or maybe there's things we've not considered for the video, and it is so useful to get those comments. But you do always kick yourself, because you're like, I should have known that.
Yeah.
But then you can't kick yourself too much, because there's so much to know about all of these things that you're always going to make mistakes. And I think something I've tried to do more as well is have humility in the fact of like, here's what I've learned, here's what the views that I've been told by experts and by the people who are making the system, but we don't have all the answers. One of my favorite quotes is, just because you're an expert doesn't mean you're right. And that's so true, because you get two experts in a room and they'll have different opinions on things. Sometimes there are just factually things that are wrong, but often it's the case that if you had 5 experts, they'd all say a different thing was the most important. So I try and use language that's a little bit less specific, or saying this is the biggest problem with a technology, which some 3 out of 4 experts might agree with, but technically there's no absolute measure of the biggest problem. So instead of saying the biggest problem, it's one of the biggest problems, or a large challenge, or something like this, to try and add some level of like interpretability. But it's always a learning expedition going down in the comments.
Oh, it is. I mean, I would say, and we're really fortunate on the Fully Charged show that 95% of the comments, maybe even a higher percentage of that, are really amazing, and we're really, really fortunate. And then there is a 5% or a 4% who like to make less constructive comments, and we skim past those ones a little bit more quickly. But I think you've raised a really interesting point around nuance, because whilst science does deal in facts, it also deals with uncertainty and the fact that things aren't completely binary. And I would say that the world of YouTube is quite binary in many respects, that it really rewards this is the best thing ever or this is the worst thing ever. And having this kind of nuanced, informed debate in the middle might not necessarily translate well into views. But I think the other component of that's interesting with regards to yourself is that you are such a technical person, and you clearly have such an ability for storytelling and communication. And those are two skills which the Venn diagram doesn't normally have a huge amount of overlap. And I'm curious to get your thoughts on just how important technical communication is to kind of keep developing and keep sort of celebrating these incredible technologies and innovations in the sustainability space.
Yeah, I think communicating like any of these technologies is just so important. And at university, and in many companies as well, more and more funding is going towards trying to get ideas out there and sharing it. And I think the way of doing that is sometimes not clear, because my videos try and get these technical ideas out to a broader audience. So you need to, I mean, they're an interested audience, but they're not exactly going to be sat reading technical papers. Some of them might not even be looking at news articles. So making it story driven and balancing the amount of technical detail is always something I'm trying to balance. My innate ability to tell stories is not great. Maybe after a few pints at a pub that I can tell some good ones, but for a YouTube script, it's something I really struggle with. My favorite part is reading all the technical research, getting an idea, understanding a system, thinking about it in detail and all the problems it might have. And then I just want to tell people about it. And that's like, I'm so passionate about sharing it. And it's great that all these universities and companies are really trying to communicate their things more, because that's how collaboration happens. But that is just something I've had to really work on to try and make it interesting. And I've brought on Sean, who helps me in research, but and also we co-write the scripts together, because she worked at the BBC. She's a storyteller by nature, so me and her have this great balance where we can uh, use each other's skill sets, where I'll make sure all the technical things are as accurate as they can be, and make sure that it's as information dense as it needs to be, but she can help me package it in a way that's a little bit more digestible, and the story flows and there's some background and all these things. So if you watch backwards through my channel, you get the storytelling worse and worse. So a large part of it is understanding that not you can't have everything. That Venn diagram isn't big for a reason. And as much as I've tried and improved my storytelling, and I still write some of the scripts myself, maybe you can tell which ones if you watch them. You'll be like, oh, this one wasn't as interesting. No, um, you can't have all the skills, and being surrounded by people that can help you with that, and be greater than the sum of your parts, is just such a secret weapon with these sort of things.
That is so true, and I think I can imagine. I'm totally going to guess here that some of your earlier scripts were maybe written more like technical papers, and sort of starting with the problem and then kind of unpicking it and then coming up with a neat
Exactly.
conclusion. That's definitely something that I've had to unlearn, I think, and kind of try and find the nugget of what do people actually care about, and that's something that I hugely credit the rest of the of our production team here at Fully Charged. They are so good at being like, okay, yeah, but why does anyone care, and really pushing and pushing. And then I think when we do sort of pieces to camera, that's quite physically challenging from an edit perspective, not least because having to hold a gimbal, that's a strain on your back. And also when it comes to the edit, you might need to mask that with more b-roll. So from a purely logistics perspective, they're pushing me to be like, okay, how can that piece to camera be reduced? And then that's great for me, because I'm like, well, I need to take that same amount of information, not lose any of the detail, but make it shorter, make it more concise. So you're right, it's such a collaborative process, and it's so vital to have people with different bits of experience coming into that puzzle, I suppose.
100%.
One of the things that really strikes me about speaking with you today, but also through going through your videos on your channel, is that there is a huge amount of optimism, and you clearly marvel at the technologies that are being developed. And I should say that they're not necessarily things like, here's a big wind turbine that you should be excited about, although obviously you do cover that kind of stuff. It will be, here's a specific thing within that turbine, for example, a blade design that makes this, an incremental change to make this more sustainable, to make it more efficient. And I wonder whether your ability to kind of really drill into the details and to see these little changes that accrue to big step changes long term, um, whether that helps keep you optimistic more broadly amidst a very doom and gloom news agenda.
Yeah, I definitely keep my head out of the mainstream news. But I am just such an optimistic person when it comes to things. Maybe on any team you need the optimist and the realist, and I definitely normally am in the optimism camp, and try and keep it aligned with reality. But these part of the reason these changes that maybe seem small to people, like, oh, you one of the videos was biomimetic propellers. I love biomimicry, and using tubercles that are on the fins of whales to try and increase the lift or propeller or the thrust or efficiency of different systems. And what's great about those is you're one taking inspiration from nature, which is just always cool, but you're slowly stacking projects on top of each other. So engineers never really, it's so rare that engineers will come up with something completely out of nowhere and revolutionize everything, but they're built on the shoulders of giants, and that always, I don't know, is something that I don't think should be missed, in terms of it's not always a complete new
Mm.
design of something. It's these little incremental things should be celebrated, because when you take a step back in 10 years time, it will be all of these little things that get us to these seemingly unachievable goals. Especially, I mean, I think electric flight is such a cool one, because it's so many of these engineering challenges, and it's never going to be a new propeller or a new battery technology or a new wing design that makes the whole plane just work on its own. And it's not going to be that, in my opinion, some vastly different system other than a plane comes along, which would be the complete flip. It's instead going to be all of those little things added together, which get us to electric flight. And that electric flight is probably quite a cool uh, case study for my channel, because a lot of the different things I look at
Mm.
build towards what, and it doesn't, what's great about these incremental changes as well is it doesn't have to be this one project. It doesn't have to be electric flight that is the use case. It's these kind of breakthroughs are like agnostic to the final use case. So with more sustainable
Mm.
shipping is going to be built off similar breakthroughs to electric flight, is going to be built off similar breakthroughs to new drones or better lighting in your house. Like all of these, when you break it down to incremental breakthroughs, they I think they excite me even more because of their, you know, wide use case. It seems like, oh, a, a whole new turbine might be more exciting because it has bigger impact in terms of absolute energy production than 1% efficiency on the blades. But when you scale those
Mm.
small more like first principle fundamental breakthroughs, um, I think the reason I'm always so excited about them is because I can see where they're going. And I do like to cover blue sky thinking projects, academic projects a lot, which by nature are quite like low TRL, technology readiness level technologies. But it yeah, it keeps me optimistic, because it also shows how, forget politics, forget what's happening in the world, forget any of that. These research groups are always huge international global projects that bring like loads of different people together. Never once have I seen a research paper that is, you know, a real big groundbreaking study that hasn't got people of at least different nationalities in different countries, different universities, different companies all working together. So I think
Mm.
all of those things keep me super optimistic, and keeping my head outside of the news
Mm.
cycle and seeing these things. I mean, I'm rambling on here, but the like in the comments sometimes you get that 1% commenter, and they'll leave a comment like, "Oh, I don't trust this. It was a Chinese innovation," or "I don't trust this. It was XYZ." And I'm like, don't like let your don't let the geopolitical news sort of murk your vision of all of the cool things that people
Mm.
within those countries are doing. Like engineering really doesn't care about your political ideology or any of these things. It's just like loads of cool people working together on these cool fundamental projects which are going to change way more things than we can even think of. Yeah,
Mm.
so that's why I'm so excited about them all, and it definitely helps keep me out of the normal news cycle.
Well, it's honestly, it's amazing hearing you sort of speak to that excitement and pure love for what engineering is. And you're absolutely right. The small first principle breakthroughs, those are the things that are going to accrue to the really, really big challenges. And I find it so heartwarming. That sounds really patronizing. Motivating, I think, is probably a better word. That there
We
are
can go for
people.
both.
We'll go for both, heartwarming and motivating. That there are people who really do care about going back to first principles and getting those incremental changes, which is so significant in their collective nature. And it doesn't surprise me that biomimicry or emulating certain engineering principles from nature is something that interests you, because nature, by its very nature, represents super, super efficient systems. I remember when I wrote my personal statement way back when for studying engineering at university, I wrote about some paint, which was, in retrospect, doesn't sound very exciting, but I wrote about this paint that was exactly that. It was taking principles of a, I can't even remember which animal, but it was so that dirt didn't stick to the outside of this building. And I just remember thinking, like, God, that is so cool. And if you even think about, the human body, it's like the perfect plumbing system. Yeah,
Yeah.
we could wang on about that all day. Okay, I want to ask you what cool stuff is currently in your content filter system that you're really excited about, that you're able to share, if possible.
Yeah. So the the content cycle, my forward planning is something I'm not the best at. So I'm only ever really looking. I have the big funnel of ideas, but there's normally, if there's two solid ideas into the future, I'm focusing on them. So I don't know. Long term, there's one more slightly different and interesting thing which I'll get to. But the next two videos, the one that's coming out tomorrow is just this absolutely bonkers turbine design, and I really went deep on this one, speaking with multiple calls with their engineering team, their head of business, experts that study offshore wind for longer than I've been on this planet. Real went deep, and because there was only really news articles around it, and I've got results from their simulations that I'm showing in this video, and it's just been an awesome deep dive to see whether it will work. And in some ways we don't know, and I'm sure people in the comments will have their own views, but that's a really cool one, because the Dunning-Kruger effect, the unknowns on that one were so huge. I couldn't even imagine how much I had to learn about that, and it's distilled into 13 minutes, so it's jam-packed, but that's a really exciting one. And then
And
there's
actually, I should say, by the time this comes out, that will have been out for a little over a week, so people will be able to see that one. We'll link to
yeah
it in the comments as well.
no, I'm very excited for that one. It just looks crazy when you see the thumbnail. You just think, how on earth is that going to work? So how, why, and if are all questions we'll explore. And then another one I'm really excited about, as we discussed, my master's thesis was on solid state batteries, and CATL, who are the biggest battery manufacturer by some huge margin, have been working on these different battery projects, and they've been releasing little hints, but nothing definitive, really. So I thought, okay, I'm gonna go down a rabbit hole there, and I've been speaking to PhD battery chemists. I've been emailing CATL's media team. I've been going through patents and every resource you can find, and gone down some. I always find YouTube videos that have like 100 views that are done by world experts on topics, but just horrifically presented. But when you sit down and watch them, there's so much to glean. So I'll find these in like the little corners of YouTube, and what they've managed to do, what they've done, and this should be a video in a couple of weeks. What they've done is nothing short of a miracle. The Chinese battery engineers. So I share an office during my PhD. I'm sharing an office with a number of PhD battery chemists, and I've been showing them this stuff. I'm like, can you just look at this? Check out what they're saying, and they are blown away by it, and they just can't believe how far ahead China is with some of this battery technologies. So
Mm.
I'm really excited. I've just been sent a final research document that from one of my experts who's been doing answering some of the questions, but it relates to solid state batteries, or an aspect of solid state batteries, which is a lithium metal anode, which is really the core thing of solid state batteries. But the way they've managed to do it is use these lithium metal anodes, which allow up to 4 times the energy density in our batteries, without actually using a solid state electrolyte, by doing electrolyte engineering. And this is unreal. So
Hang on. Okay, so I'm just going to check that I've understood this. We should have had the whole podcast about this alone. But so normally you have lithium ions and they're within a cathode structure of various other bits and bobs. But this is saying actually get rid of that cathode structure. It is lithium metal purely that accrues on that side of the. Well, I say get rid of the cathode. It would become the cathode, but you haven't got like a NMC situation
so
going on.
not quite. The way
Okay.
it's normally laid out in a very rough part is you've got your anode, cathode, and electrolyte and separator and things in between your anode and cathode. Then your cathode is these NMCs, your LFPs, your mixture of some lithium sort of composites. Then you've got a graphite anode, which is what sort of all the lithium ions intercalate into, and sort of live in, and they come in and out for during charge and discharge. So solid state batteries say, let's take the graphite anode out and replace it with lithium. So now you have lithium on both sides, which gives you this huge electrical voltage potential. Like it's just massive increase in energy density. But the issue with this is that you have dendrites that want to grow. It's kind of like Japanese knotweed, and they want to pierce through and make the battery go bang. And if you have a solid electrolyte, the idea is that it stops those dendrites. So now you're not, you now have double lithium almost, but they're really reactive. So you can block the dendrites with this solid electrolyte. But that's actually quite a hotly discussed topic. Are they actually blocking the dendrites? Are these solid state batteries actually safe? And the interface between that solid electrolyte and your anode and cathode is really important. And part of the reason why some of them can't be used is because that boundary, that interface between your anode and cathode and your solid electrolyte is really poor. This is where the solid state electrolytes that I looked at are better, because they're polymers, they're kind of malleable, and they create better boundaries. But instead, CATL have said, screw that. I don't want any solid electrolytes. What really is important here is that we have lithium on the anode and the cathode, and that we stop dendrites. That's really the point of solid state batteries. It's not so much that we're trying to make them solid state. That was kind of seen as a benefit, but in hindsight, a lot of the literature says that's the only real reason we're doing this is to have lithium, and stop dendrites. Well, CATL have said, can we specifically engineer parts of the electrolyte as a sort of gel with biomimicry as well? That's all put in there as well, with how they've aligned polymer chains to make a dendrite resistant but non-solid state battery. So this is completely rewriting the rules of batteries, and they say that, and there's no reason not to believe them. This is a company that always back up their claims, as crazy as they sound, that they've got large electric aircraft flying using these batteries. It's just super interesting. So I'm still in the learning phase, and I'm a bit of there's a few unknown unknowns, but I've got experts helping me that I'm sure will illuminate.
Oh my goodness. I should say for anyone who's listening or watching this that we'll also link to the Ewan McTurk battery episode that we did on the show at the end of 2023, where we kind of go through some of the major key chemistries. And I think they paint quite a good landscape as to why this is also particularly interesting. But I really enjoy, you can almost imagine the conversation that would have happened at CATL, where they're like, yes, how do we stop these dendrites forming and shorting batteries? And obviously that's why we're doing solid state. And then they were like, hang on a second, get rid of the electrolyte. Let's get rid of the middleman and we'll come up with a whole new thing.
it's a
that is
perfect
blue sky
example of
thinking.
it is. It's blue sky and it's lateral thinking, where it's like we don't have to, you know, you don't have to keep going on the same direction. Sometimes it's like, actually, let's just explore this route. So anyway, I'm super excited about both of those videos, partly because they're the first videos where I've really utilized my sort of expert panel, as I call them, where I've really got multiple experts along with company people and just gone deeper than anyone would think you should on these topics. But that one's super interesting. And then the last thing that I'm really excited about is I've just brought, it's actually somewhere in here, and a remote control electric plane, which is about a meter and a half wingspan. And as I was saying, electric planes are a perfect test bed for all of these sort of iterative improvements that I cover on the channel. I've now got a test bed where, with my 3D printer, I can start. I'm going to be printing propellers, interesting ones, and taking to the sky. I'm going to be trying different wing designs, and putting, uh, tubicles like on uh, humpback whales. Is that the right whales? All these things on my plane and testing to see the efficiency and how it does it, just to try and make it less of always such an academic pursuit, and have some real life engineering going on as well, because that's always reveals a whole new world that you didn't expect or didn't anticipate.
That is so cool. And I have to say, one of your sponsors is a 3D printer machine. And watching videos, I was like, God, I need a 3D printer. I don't know what I'd 3D print, but I would certainly find something to 3D print. But then as I
So
was
good.
thinking that thought, and I actually wrote myself a note here, there was an advert that popped up. Not one of your sponsors, this was just an advert that popped up during the episode. But I thought it was interesting what the algorithm, or who the algorithm thought that I was. And it was like, bearskin waterproof tactical jacket for rain insulation. You can dump heat with your armpit zips. And it was like, honestly, this is like a 3-minute long advert, and I was compelled. So part of me was thinking, God, they have totally misjudged me as an audience for this jacket. By the end, I was like, yes, I do
They knew you better than
need
you knew
9
you.
insulated pockets. Yeah. It's absolutely incredible. Oh, okay. We have been talking for a good 55 minutes, and we could continue for a further 55 minutes, but we absolutely should wrap these things up. I guess my last question then for you is, you are clearly a very, very talented engineer. You're clearly a very talented content creator, talking about all things engineering and sustainable engineering in particular. What do you want to do when you grow up? What's the sort of the
God,
vision? Because I know that your PhD comes to an end this October. So what's next?
it does. Yeah. So it ends in October if the timelines work out, which they're looking good at the minute, but we'll give it a little bit of leeway either side. But thankfully, awesome sponsors on the channel and so many people watching the videos, it's meant that I will be able to basically go full time into YouTube, which is all I've ever wanted to do. Like, I've been making videos on Ziroth probably for just under 4 years, but I've been making regular YouTube videos for about 12 years on different channels. So this is one of the chapters of YouTube creation that I've been on. So I'm just super beyond excited to be able to put more time into YouTube. But the great thing about the Zeroth content is that it's not just making YouTube videos. I'm going to be visiting in person with more companies and spending even longer looking at these ideas. So the short answer is YouTube and carrying on, but more broadly, it's going to be expanding the operation. But and I'd definitely like to do more in-person things with it. The time just doesn't allow it, but be that teaching and doing things in person with classes, as well as visiting more companies. So that's the short-term answer. But long-term, I just love creating things, and I love engineering, and I love making videos. So that there's a whole world that could take me down long-term. But very excited to have more time for those projects.
Well, I have to say that I'm personally hugely relieved to hear that answer, because I have learned an awful lot from your channel, and I really hope that anyone who's listening to this who hasn't discovered your channel goes away and goes down many, many, many Ziroth-shaped rabbit holes, because it's brilliant and you won't regret it. But thank you so much for giving up your evening. It's wonderful to chat, and no doubt we'll catch up soon.
Yeah, 100%. Thank you so much for having me on. It's a real pleasure. I've been a fan of Fully Charged for so long. Went to some of the early Fully Charged shows, and it's great to be on.
Oh, no, thank you. Thank you for joining us. Goodness me, I so enjoyed that conversation with Ryan. It is so refreshing to marvel at the engineering world and to take real delight and wonder in it. That is all that we have time for. Thank you very much to Ryan for joining us. Thank you to Katie, who will be editing this episode. Thank you to you for joining us. Before you go, I have one very quick favour to ask. If you could like, comment or subscribe to this video or episode, it is so helpful and does mean that we can keep on sharing the stuff that we find important and cool and interesting in this clean energy transition. But that's it. If you have been, thank you for listening.